We treat semiconductors like the oil of the 21st century, but unlike oil, which a country can just pump out of its own ground, absolutely no single nation on Earth can build a modern microchip entirely on its own. Instead, creating these chips requires a global assembly line. This value chain is stretched across continents, and at almost every crucial step, an extreme monopoly operates a specialized choke point. This flowchart maps out that process. American companies dominate the software and intellectual property required to actually design the chips, but to physically print those designs, they have to rely on European firms who maintain a total monopoly on advanced photolithography machines. Once the design and machines are ready, everything is shipped off to Asia. Taiwan and South Korea control the actual fabrication, or foundries, and the final packaging and testing stages. The result is a highly efficient machine, but a deeply fragile one. A disruption at any single one of these physical bottlenecks can paralyze the global tech economy. To understand why these bottlenecks exist, look at the massive physical scale required. To actually build these components, facilities like TSMC's fabrication campus in Taiwan are multi-billion-dollar megastructures. The barrier to building one of these is so high that even the biggest AI companies in the world don't manufacture their own hardware. They are entirely reliant on these third-party foundries to turn their architecture into physical reality. At the cutting edge, printing circuits smaller than 7 nanometers, the financial barrier is astronomical. A single extreme ultraviolet lithography machine required for this process costs upwards of $150 million. With superpowers pouring hundreds of billions of dollars into the race for 1 and 3 nanometer chips, emerging economies find themselves entirely locked out of the bleeding edge. Trying to match that capital expenditure dollar for dollar is a quick path to financial ruin. To survive in this supply chain, they have to find a smarter, more pragmatic entry point, which brings us to Vietnam's deliberate strategy. Instead of chasing the 1 nanometer mirage, state-owned tech giant Viettel is building a fabrication plant strictly focused on the 32 nanometer process, a category known as a mature node. It sounds like a step backward until you look at what actually runs the physical economy. While iPhones demand 3 nanometer silicon, the critical infrastructure around us, automotive braking systems, telecom radar, and defense equipment, relies almost entirely on highly durable 32 nanometer chips. This chart shows exactly where the gap is. Notice the severe unmet demand in the 22 to 45 nanometer segment. By 2027, mature nodes are projected to account for 24%. Sticking to 32 nanometers also solves the capital expenditure problem. It bypasses Western export controls on those $150 million EUV machines. Instead, Viettel can use older, refurbished equipment, drastically cutting upfront costs and accelerating their return on investment. This is a highly calculated value investing play, designed to capture a massive, permanently underserved segment of the global market. But fabricating the silicon is only half the battle. A raw wafer like this, straight out of the foundry, is commercially useless until it is individually cut, tested, and packaged into a protective casing. That downstream gap is where the private sector steps in. Vietnamese tech conglomerate FPT already proved their design capabilities by successfully exporting commercial power management chips to top-tier buyers in Japan. Now they are moving to capture the physical back end of the process. In 2026, FPT is establishing an advanced semiconductor testing and packaging plant in northern Vietnam. This diagram illustrates their overarching blueprint. You have the state-backed muscle of Viettel, handling the heavy, capital-intensive front-end fabrication, feeding raw wafers directly into the agile private sector engine of FPT for back-end packaging and commercial export. This synchronized public-private alliance establishes a complete, integrated pipeline for these mature node chips, positioning Vietnam as an indispensable link in the regional supply chain. So, from an investment standpoint, what happens next? When a country establishes this kind of foundational hardware ecosystem, where does the smart money actually flow? A semiconductor hub pulls an entire support structure along with it: high-tech industrial real estate, specialized logistics networks, and massive industrial utilities to guarantee uninterrupted clean water and stable power. But the risks here are severe. Vietnam faces fierce regional competition from established hubs like Malaysia. They lack domestic ownership of core intellectual property, and they are currently staring down a critical shortage of the highly specialized engineers required to actually run these plants. That is why smart capital ignores the immediate tech hype. Instead, it positions itself firmly in the concrete foundational infrastructure that has to be built before a single microchip can ever be exported. To succeed, Vietnam doesn't need to dominate the entire global semiconductor chain. They just need to dig a wide moat around one highly profitable, completely indispensable link.